Welcome, everyone. Has everyone had a good conference so far? So what I'd like you to do, this is my favorite conference of all time. I love coming to Oslo, I love NDC, and I think that the organizers deserve a big round of applause. Cheer as much as you can. Woo! Awesome. I truly do love all the conversations we have in the hallways, the discussions we have around programming languages, and everything that we can learn from each other. So for the next hour, we're going to be talking about what's new in C#, how this programming language has changed, and the language features that have been introduced in C#, which change the way that we try to express ourselves. And I do bet that if I get invited back next year, this talk will be titled, What Used to be C# and What's Now F#. And you'll soon see why. There's quite a lot of influences in C# coming from functional programming languages. I'm Filip Ekberg. I've been here quite a few times. I've got some courses on Pluralsight covering mostly C#. So if you like my stuff, check that out as well. And I'm always available for questions. Send me a DM on Twitter. Talk to me about programming languages or just life in general. I'm always available. With that being said, we're here to talk about C# and how this programming language that we all hopefully love, we want to know how this has changed. Now, there are quite some features in C# that have, over the years, changed how we express ourselves, fundamentally changed the way that we architect our applications. Language features such as generics, being able to use lambdas, being able to use LINQ, asynchronous programming using async and await. But not every version of C# introduces those kind of groundbreaking features. But there are some changes from C# 8 and onwards that do change this as well. And the reason that it's still possible to add things to a programming language. I mean, C# has been around for a very long time. The reason they're still able to add language features is because it's now open source. Everyone can participate and, add their comments to programming language designs, talk about what do we want in C# as a programming language. We can participate in these discussions, or if you really like programming languages, you can even participate in sending pull requests. So they've got the compilers as an open source project. And what I think is most important about this is that I can go ahead and look at the ideas behind these features. What's the reasoning behind adding more things in C#, right? And I think that's valuable. Maybe it's just me that like to spend time on GitHub reading about language stuff, but I do really like C#. And with that being said, C# 7 introduced some groundbreaking features. But at the time, it wasn't really something that you'd use, because they waited until C# 8 to fully make use of these language features. So I promise that we're going to talk about C# 8, 9, 10, and possibly even what's coming in C# 11. But before that, there's two language features from C# 7 that I think are important to understand before we go on to talk about C# 8. Now, C# 7 is the first and only version of the language where they did point releases. I believe this is a proof of concept that since the compilers are open source, they can release this independently of Visual Studio and release it as an updated NuGet package, for example. They did some changes in C# 7.1, 7.2, 7.3, just to prove a point. But what they did introduce is something called tuples, or tuples, depending on how you like to pronounce them. We're talking about the same thing. But this has always been available in .NET. This here is tuples in older versions of C#, or in .NET, rather. But this here becomes a little bit tricky to work with. This container of multiple different values, it's quite useless if you have to access item 1, item 2, item 3. It would be better if this was, like in every other programming language, a first-class citizen. So what they did was that they introduced this as a first-class citizen. We can now define a group of elements that belong together, very much like a class or a struct, but it's more condensed, like it's created in place, instead of having to create a new file. I guess it's all about saving characters, right? This can be used to return multiple values from a method, or accept a parameter with multiple values. But why would you use this in C# 7? There are some use cases, but where it's really powerful is when we introduce pattern matching. And that's one of the last things we'll talk about in this talk, so just keep this with you for now. Tuples is a groundbreaking feature in the language that has been around for quite some time in other places. Together with this, in C#7, they also introduced a way to look at objects differently. Imagine that we add this very magical named method called deconstruct. Don't confuse this with a deconstructor or a destroyer or a whatever it's called in other programming languages. It doesn't have anything to do with the construct or garbage collection or anything like that. What this here is doing is that it introduces a way for me to pull an object apart and treat it and assign it to different variables a little bit differently from what you're used to. If I add this to any type that has these properties that I can set on my now out parameters, I'll be able to do this. I can say, take my instance of a person, for example, and now initialize 2 local variables using that method. Quite great, but still, it's a feature that, alone like this here, I probably wouldn't find a lot of use case for this. Where, again, this becomes useful is with pattern matching. And we'll see that soon as well. So why this is interesting is because they've introduced features in older versions of C#. And they're going to keep doing this, adding small features that might not make sense now, but in a few versions from now, it's going to make a lot of sense, because you have the entire picture. Now, this here comes together, like tuples and deconstructions. You can take a tuple that you have in the right-hand side here, and you can deconstruct that or do a tuple assignment, and this will now belong in a completely different type of representation. It's useful. But where it's even more useful is if I can take an instance of that class and say, hey, how about you deconstruct this and assign this to 2 new local variables? It's pretty powerful, and it's all built on top of this concept called a deconstruct. You can have as many of these as possible, and if you're using record types, which is also something we're going to look at, all of these are auto-generated. So C#7, that's years ago, right? This is a feature that's been around for 5+ years. But it was only until C#8 and a year after that, or a couple of years after that, that this became useful. So in C#8, it feels like with the 8th iteration of the language, shouldn't C# be completed? Well, if it was, I probably wouldn't be standing here talking about all the next versions. But there's still a lot of things that we can get into the language which will help us express ourselves a little bit differently. Saving characters, making our code more easier to read, and ultimately making it easier to maintain. We've covered quite a few of these here, but C#8 introduces something known as read-only members. It introduces a concept of default interface methods or default interface implementations, depending on when you read the documentation last. Kind of tend to change names a little bit. Then they introduced some pattern matching enhancements. So C#7 actually introduced a first version of pattern matching. I haven't covered that yet because, again, that's something that wasn't really useful until C#8. It has a few more really great features. We're not going to be able to cover all of these. But then another groundbreaking feature that we're also going to spend some time talking about is nullable reference types, a new way of looking at reference types in our applications, being able to spot when something could blow up before it actually does. Sounds magical, and hopefully we'll all go away from this and use that in our applications. They introduced asynchronous streams, a way for us to work with asynchronous data, asynchronous disposables, ranges and indices, null equalizing assignment. There's quite a lot inside C#8. Right? To use this, we'd have to use a very specific version of .NET, and this is where it becomes a little bit confusing, because we won't have time to talk about the difference between .NET Framework, .NET Core, the new .NET, and everything that's going on with the naming and all of that. Let's just say, use the latest version of .NET, and you'll be fine. You can use all of the latest and greatest of C# as well. But as you see here, C# relates to the version of a specific runtime. And that's because C#8, for example, was the first language version in a very long time that depended on runtime changes. So they had to ship this as a part of the process of shipping the runtime in .NET as well. And the same goes for some new features in C# and .NET as well. You probably want to jump on the latest LTS version, the long-term support version. I've been talking about C#8 and some of these older versions for a few years, but it's only now that this is first getting traction, because now people are starting to use .NET 6, which is going to be supported for quite some time going forward until the next LTS version comes around. So if you're working in an older project, you're probably thinking, well, I've got a WinForms application or a WPF application that's running on Framework. I want to update this to use .NET Core or the latest .NET. The great part is that we can actually do this now, and we've been able to do this since .NET Core 3.1. So you can create a WPF application, and you'd imagine that you just toggle a switch and it just works with the latest version. But that's not really the case. You'd have to bring all your files over and so forth. But that would let you leverage all the latest versions or all the latest language features of C#. So if you have Visual Studio 2022, you'll be able to use the latest in C# 10. And in a couple of weeks, I believe .NET 7 is just around the corner, and that will also come with a new version of C#. But it'll take some time before that has some traction, because again, that's not a long-time support version. If you happen to be writing libraries that target different types of runtimes, and you try to use a language feature that's not supported, C# 8 introduces a language feature called default interface methods. This is only available if you're targeting .NET Core 3.1 and later. So then you'll get a compiler error saying that, well, the runtime you're currently targeting doesn't support this feature. But what's interesting here is that we can use language features even if the runtime is unsupported, because a lot of these language features, it's just compiler magic. If it's capable of compiling the code to something that an older runtime understands, you'll be totally fine. And the compiler will do its best to tell you if you're doing something that you shouldn't. Speaking of this unsupported default interface implementations or methods, whatever you want to call it, same thing, this is something that tends to divide people into two different groups. Personally, I'm not very fond of this feature, and a lot of other developers really hate it. So either you hate it, or you simply don't like it that much. So I have no clue why they decided to add this to the language. So default interface methods, imagine that I have this interface here, super simple. I provide this through NuGet or GitHub or whatever. This is an open source project, super popular. Now I want to update this with a new version that's generic. Now I can add a method body to my interface, which is quite odd, because this means that my interface can now contain implementation details, can contain logic that it shouldn't. So it looks like a class. The only difference is that it doesn't have an instance. But I can still have a lot of code here. So it could end up in a situation where it feels like it's multiple inheritance. And a little gotcha here is that if I have an interface that has this default interface method, and I try to automatically implement this interface, it's not going to generate that method tget of t. It's just not going to tell me that it even exists. So the tooling around this is also not perfect. It's a bit to ask from that. So with that being said, is anyone here going to use this or have already used it? A couple of you, yes. Static. So the good thing about this is for library developers. If you have a very popular library out there, I understand why you would want to use this, because that means that you could update your library and have a little bit of a documentation that everyone should read the documentations for every library that you use. And then when you update that package, you have the option to override or implement this method. You won't break anyone. Because if you break people's code by just supplying a new NuGet version, people are going to get pretty upset. So I did promise that there are a few things that are, I'm not just going to say groundbreaking, but there are things in the programming language that architecturally change how we look at things. And it helps us drive our development in a direction that makes the applications better. Things like generics and asynchronous programming and all of that change exactly how we interact with libraries in a better way. Nullable reference types is one of those things. It's one of those things that in the future, we're going to be asking ourselves, why didn't we have this from the start, or an alternative of this from the start? You could ask yourself, why did C# allow nulls from the first place? Back in the day, that was what every programming language did. If you design a completely new programming language, or you start off from something and you create Kotlin or Swift, you make it hard for developers to use nulls, because they're going to end up with something like this. If you haven't gotten this yet, either you just started development or you're lying. Because you will end up having a null reference exception. Now, nullable reference types is a way to work around the problem. It's a way to work around the fact that we have nulls in C#. The best would have been to go back in time and say, hey, you're not allowed to use nulls. But that would probably have other architectural changes and differences as well. So there's a few fundamental problems with nulls, right? The biggest problem with nullability is that it promotes that we have null checks all over the place. It's going to clutter up the code. There's unnecessary code. How about if I know that there's never going to be a null reference exception? I always feel like that, but it blows up anyways. But let's say we're sure this is never going to throw any exceptions. It would be quite unnecessary to clutter the code with more null checks. And then I guess another big problem is, what does actually returning null mean? If I have a repository, I'm asking for a user from the database, it returns null. Did that mean the database operation failed? Did the user not exist? Or was there some other problem? So returning nulls is a really problem because it's ambiguous what we mean when we do that. And it also encourages mutability. That means we can change the object. If something's null, we are expecting that this is going to be set later on, which is problematic in multi-threaded applications. It would be better if we just couldn't do anything. Everything was just read-only. Once you've created an instance, it's there. You can't change it. In the real world, that doesn't happen. So I tend to end up writing code like this. And I know most of you are probably thinking, well, you can write this much more pretty with all the language features of C#. Surely enough, I can. But if I can trust that this isn't null in this situation, wouldn't it be better if I could trust a compiler to tell me if this was an actual or potential problem? We can do that by indicating to the compiler that we enable this thing called nullable reference types. What this does is that it completely changes how the compiler looks at strings, objects, everything that's a reference type. By default, it's going to change so that nothing should be null. It's not enforcing it. There's not going to be any problems if you set something to null, except it's going to tell you that, hey, this thing here could potentially be null, which is great. This here is pretty obvious that it's null. Even I can see that. So here, it would be great to have a null check or a null conditional operator. But of course, this is a very simple example. There's much more complex situations where the compiler can be much smarter than I can. There's something called null state static analysis, which is really hard to say a couple of times right after each other. This thing, what it's doing is that it's trying to track the null state of everything. So if I pass name here into a method and it promises that it checks for a null, we can indicate to the compiler that we've performed a null check. And this error would have gone away, which would have been awesome. We're going to look at an example of that soon in Visual Studio. Now, what you can do with this here, it's just going to provide us with a warning, which is good. But honestly, if we have a big project, many of you can maybe work in really large solutions. So if you go ahead and turn this on, you'll have like 1 million warnings. And if you're like me, you're like, oh, ignore. Someone else will fix that, or we'll add a to-do. But what you can do, you can treat warnings as errors. So what I suggest, you go back to work, you enable the nullable reference types, you turn on treat warnings as errors, so that every time you build, there's going to be a compiler error. You commit that into source control, and then you leave work for a few days. That's going to be super popular. Probably don't want to do that. So let's have a look at what this feature actually can do and how it works in a real application. This here is a very simple console application. I have a few classes here. There's no errors found. Everything is supposed to be working perfectly fine. I know that it doesn't. So by looking at this code here, it looks fine. It looks like the data classes or the data models that we normally write. But there are a few problems in this application. And if I enable this language feature, I can do it in 2 ways. I can use a compiler directive to enable this, which is now going to show me a few warnings here. But I can also go into the csproj file or do it from the project properties. And I'm going to be hurting myself and enabling both nullable reference types. The compiler will now look at my types as this shouldn't be null. And then I'm also going to get compiler errors for every time it finds a warning. Now, if I save that and just wait for a little while, let me do full screen here. Here we go. Now we have a couple of compiler errors, right? And that's totally fine. In this very small application, it makes sense. It's easy for me to fix these problems. But how would we go by fixing this issue? There are a couple of different alternatives. We can introduce a constructor. If I introduce an empty constructor, it's going to move that warning or error to the constructor, because the compiler deems that the constructor should be in charge of actually constructing your object and accepting the correct parameters. So what I can do here is that I can say, well, give me the first name, and then give me the string last name. And I could initialize this, and it would all, not that one, first name is equal to whatever I passed into this method. And let's do this as well. Now, there's no more warnings. But the problem here is if we go back to work and do this, we're going to break everyone that's using this class. They now have to pass these parameters into the constructor. So another alternative would be to say that I actually do support these to be null for now. I don't want to ignore that they could be null, but I do want to say that I allow you to be null, so that whoever else uses this would be notified. I can do that by adding a question mark. And now I'm saying string can be nullable, which was the previous default behavior. And we'll say that about this as well is that in C#6 and onwards, this feature is turned on by default. So nothing should be null. It will complain all over the place. OK, so in this person class, it's the same thing. It uses this details class. And honestly, this isn't where the null reference exception would occur. The null reference exception would occur somewhere else where this here is being used. What I really want this class to be doing is two things. One, when you create an instance, I'd really like to require that you set this to an instance. We're getting ahead of ourselves here, but there's a new keyword in C#11 called required. If you add that to your property, it would require you to set this to an instance in the object initializer. This doesn't require you to add a constructor, but it kind of works around the fact that you don't want to introduce the constructor. And this then can be used in conjunction with this init keyword, which is an init-only setter. It means that you're only allowed to set this once. So after you've set this to an instance, you can't change it. It will be immutable after that. All right. Back to the nullable reference types. Person and detail, or person, the details of the person and all the details inside of it, they can all be null, and that's fine. But now we'll notice that I have a couple of more problems. And the compiler is now smart enough to figure out that inside this method, which accepts an IEnumerable of person, a collection of people, so to say, I know that this here is going to be an instance, because otherwise I would have to mark this as being nullable. So it just automatically checked that this wouldn't be null. Notice that I got a problem here saying that this is potentially null. That's perfect. Now, of course, I could add a null conditional operator, but then again, I end up cluttering my code a little bit. In some places, we have to do this. But this here was actually finding a null reference exception. Because if I ran this application and hadn't set an instance, this would blow up. But let's say that I know better than the compiler. Let's say check for null. I don't have this method. It doesn't really matter. We can do person.details. Let's say that I've checked that this is null, and now, therefore, I know I can use an exclamation mark. It's also known as a dammit operator. Because dammit, I know better than you. You, most of the case, you don't. But it's a way for us to ignore that we got an error. But let me get rid of that and show you another alternative approach to this. And we'll get back to the dammit operator soon. So either I could check that with the null conditional operator, or it tracks the null state. Remember I said that earlier? So I could say if the person's details is not null, we can go ahead and do this, right? And then it just knows that I've checked this already. It knows that inside this block, it's not going to be null at all. But it doesn't have to be in the same if statement. If we invert this and say if it is null, it's going to continue to the next one. There we go. And it just knows. So we have some options here, which is really great. We can now track down potential null reference exceptions. And this here would have blown up. But there's one more error inside this application where it, in fact, is causing a bigger issue. And I know that it's in this method here that's telling me I should return an instance of something that's an INumerable of person. But this here is returning null. A little bit problematic. But again, I can promise that I've null-checked null, and the error disappeared. This is why you don't know better than the compiler. Things will blow up. There's no problem doing this, other than it looks odd. There's not going to be any compiler errors. It's not going to blow up just because you do this. But it's, yeah, it just illustrates why it's problematic. So instead, what we want to do, we want to return an actual instance of a person inside a list. And now I'm going to return a new instance using yield, because if I do yield return, that's going to allow me to not have to create a temporary list. It's going to allow me to then iterate through this INumerable, and I can just say return a new thing. This here is called a target type new expression. And what this here is doing, this part here, is actually creating a new person. Because it figures out what I want to return here. Yield return produces an enumerator, and I can say, I want to create some new details as well. It all becomes very beautiful and sometimes hard to understand and read. And I can type. Here we go. Right? And now I've fixed all the null reference exceptions inside this application. This was a very simple one. But at least it let me track down what could potentially be causing some really annoying issues in this application. This is the first thing that I see a lot of developers turn on in solutions that either they start from scratch or if they come into a new project. Turn it on, figure out what could be potentially null, learn the application, learn the code base. But if you're new to a project, don't turn on treat warnings as errors and check in the code, because you won't have a project anymore. With that being said, there's one more feature. So this drastically changed, actually, in my opinion. It changes how we look at building our software, because now we are told by the compiler that things could be null. We don't have to clutter with if actually, let me show you this. Like back in the day when I didn't have this feature, I would safeguard against everything, right? I would do if people is equal to null, then return. And if, you get the point, right? You'd have all these if statements, but if I know that whoever tries to send null into this method would get a compiler error or a warning, then I can trust that it's been null checked, which is pretty cool. So it changes the way that we look at nulls and building applications that uses reference types. A better alternative would, of course, always be to have a default class or a default instance of a class. But that changes the way that you think about your applications even further. Speaking of thinking differently, let's talk about asynchronous streams, which is a concept introduced also in C#8, which, again, if you don't know anything about async and await, this is going to be very complex and very hard to understand. But basically, let's try to make it simple. Let's say that I have this method here. I want to be able to stream data to someone that consumes this method. That means that I can send them one item at a time. This here returns strings. And this return type indicates what type of data will be streamed back to whoever uses this method. I can say that every time you call this method or every time you use this, it gives you a string back, which is nice. It's marked as async because it's going to retrieve things asynchronously. But we haven't introduced that part yet. Now, where all the magic happens is this yield thing. I showed you this just now with the nullable reference types. The yield keyword has been around for a very long time. It's a way to send data back to the for each loop. But in this case, the for each loop is going to retrieve each element asynchronously. So this here tells the iterator that there's a new item to process. And in this sample here, I'm going to retrieve everything asynchronously from the file system. This line of code here can be written very differently, and I've actually written it a little bit differently in VS Code, which we'll see in just a little moment. So what happens here is that it reads a file, or it starts or opens a file on disk using this using declaration that you see here at the top, and then it's reading a line at a time. This means that we don't have to load the entire file into memory. We don't have to load too much data. We can skip or stop whenever we want to. And then just to simulate some processing, I've added a task.delay. Sometimes a thread.sleep or task.delay just magically fixes problems. It really doesn't. But here it's just added to simulate that we're doing some work. Maybe it's storing this in a database. Maybe it's processing this somehow. But does that on a different thread. Producing this stream of data looks very complex, but consuming it is even simpler. So what I do here is that I say that await for each. So we put this await keyword in front of the for each loop to indicate that each item will be retrieved from this stream of data asynchronously. So what does this actually look like? If we jump over to VS Code, I've got this exact same code snippet, except there's one change in here. I've changed line 12 here. This line here doesn't look as, in my opinion, this looks a little bit more pretty. But if you're totally new to everything around pattern matching, which we're going to talk about later, so I'd be surprised if you knew all of this already. But it's a little bit more of a fluent way of writing the same thing. But again, I'm producing a stream of data here. I'm indicating that I want to return strings. I'm going to start off and open a stream to a file on my disk. This is a using declaration. Normally, you see this as a using statement, which would look something like this. You'd add it in parentheses here, you'd have a curly bracket here, and you'd have one more layer of indentation, right? We've all done that, but now we don't have to do that anymore. It's a little bit more fluent. And what it's also making sure of is that it's going to be disposed of after this entire asynchronous processing is completed. So then what I'm saying here is that give me a line or the next line if this is an instance of a string. I want you to store that in a local variable called line. If I wrote var here, that would actually capture nulls as well, which would make this an infinite loop. Because each time it tries to read the next line, if there's no line to read, it's going to be null. So therefore, we have to be specific about the type that I'm expecting from this call. Otherwise, it will not work as expected. A bit of a task.delay, then using yield return to return this back to the consumer. OK, perfect. So now we have this await keyword in front of a for each loop. If you've done asynchronous programming, you've probably seen that if you add the await keyword in front of the method call, that will run that method asynchronously, right? But this here would indicate that give me the entire chunk of data, while this here means give me each item one by one. The body will run, and then it will ask for the next element, and then it will ask for the next one, and so forth. It's rather simple and rather nice. So let's run this and see if it works. Hopefully it streams my favorite song out to the console. If you don't know the song, welcome to the internet. So with that being said, I think asynchronous streams are pretty powerful. But of course, this is a very simple example, reading a file from disk, getting one line at a time. Where I've used this and seen this used in production is with things like Azure queues. You have a message bus in Azure, and you'd like to subscribe to when a message arrives. Instead of having a while true loop, ping Azure, give me the next message, you use this very concise syntax that we have with the iasync enumerable, right? There we go, this one. So what this is actually then letting us do is saying, when there is a new message in Azure, give me the next one to process. And you don't have to build any long polling yourself. It will just figure that out. So the APIs are really nice like that. So before we talk about pattern matching, there's a few things in C#9 that's also made it easier for us and better to work with pattern matching. That's something called records, which is a new type of reference types. I've already shown the init-only setters that makes properties truly read-only because you can't change them. There's a thing called top-level statements, making it easier for us to write console applications or something known as minimal APIs. There's quite a few things happening in C#9 as well. I'm not going to be able to go through all of this, obviously, because we've only got 25 minutes left. Unless you want to stay until tomorrow morning. I don't have anything planned. So with the 9th iteration of C#, there's still quite a lot of things added to the language, right? I think it's pretty amazing that they're trying to look at other programming languages. What's appealing to developers from Kotlin to Swift, in Java, in many other programming languages, and take the best of that and make it so that it feels like a C# language feature. Now it's time to talk about pattern matching, which again is one of those features that will change how we build and write our code. The idea is that we can express ourselves to find things in instances of objects a little bit differently. Maybe use a language that is closer to the business. Because if you show some piece of code to a product owner, like I don't know why you would do that, but if you do, and they want to understand exactly what's going on, then pattern matching, in my opinion, reads much nicer than what traditional code does. So it's a way for us to determine, like, how many edges does this puzzle piece have? How does it look? What kind of color is it? Is the fruit edible, and so forth? Like, we can use this until our imagination stops. There's so many things we can do with pattern matching. But we've been able to do this before as well. For example, I can check the type and check if it has a certain color. Then I would have to cast this into the correct type before I can use that. Which isn't too bad. Like, this is some type of code that we've all written, and we've lived with this for a very long time. And the reason I didn't show this with C#7 is because I wouldn't say that the syntax or the amount of code that we had to write was less code. It looks a little bit more cluttered. There's more characters doing the same type of thing. But this here, in C#7, was the first piece in getting pattern matching into the language. We can now use a switch to look at a type. Inside the body here, or inside the case here, I can say that when this is an apple, I'm going to capture that as the concrete or the correct type. I don't have to do any type casting myself. It will just work automatically, which is very nice. But in C#8, this changed quite a bit. They introduced a new concept called a switch expression, which looks very different from what you might have seen in C# before. So here, I want to get a result based on what an object looks like, or what the instance looks like. So this here, the input, is the object we want to create different patterns for, right? And then I can fill this with expressions to say that, what type is this? What kind of properties and values does this have? What does it deconstruct to? Like, we can fill this with very, very complex and simple patterns. Here's an example. If it's an apple, just return the text, this is an apple. So just the same as expression-bodied members. After, on the right-hand side of this arrow syntax, you have a return value. Could have been a method call, right? So this is what's returned from the pattern. This here is very powerful, but this is just checking the type. And the discard notion that we have here captures everything. It matches null, it matches not the same type you're looking for, and so forth, right? It matches all the things. But checking the type, that's just kind of a small piece of what pattern matching can do. So therefore, C#8, 9, 10, and 11 introduces quite a lot of patterns. And it can be a little bit overwhelming as to where you would use this. But we're going to cover a few of them. The type pattern I've shown you. You check if a type is a type. The is string, right? We can check if an object can be deconstructed into an exact constant that matches what it's deconstructed into. So that deconstruct that we had earlier, that maybe it took the age or the address, you could use that to check something using a pattern. More often you use a property pattern, but you can also do this with tuples. You can say that given an instance of a user, if this user has not logged in for the last 30 days, it should be locked out. Or it should ask for verification through an SMS. Like, you could do a whole kinds of interesting things and express yourself using patterns. Another example is you could say that a user needs to be at least, or somewhere between 10 and 40 years old, for example, or 20 and 60. Which also lets us use an OR pattern, parenthesized pattern. You can negate an entire pattern, say it's not null, for example. And all of these together builds up something called a recursive pattern. You can say if it's a successful attempt, you've logged in, it's successful, but you haven't logged in for 30 days. then we do something. That's a recursive pattern. It checks one piece at a time. Let's spend some time in Visual Studio looking at exactly this. I've already introduced a new console application, and being good at naming, I will just call it Console App 2. This here introduces a concept, or a few different classes. Notice that it says record. This is actually, behind the scenes, this is a record class. By default, records are classes, they're reference types. And we get quite a bit of functionality out of the box. Before I show you how to use this with patterns and pattern matching, have a look at this piece of code here. Here's a very simple record, person. This here is a constructor, or default constructor, primary constructor, sorry. It's required to take a name and an age. And when this is decompiled using, in this case, SharpLab, the code to the right-hand side, there's quite a lot of code in here to create this reference type. We have a person that implements iEquatable. It has the backing fields. There's quite a bit of code that's introduced when we use this new type called a record. And the reason we do this is because it uses value-based equality. So if I have two people with the same names, it would compare the values rather than the reference. And this also introduces what I told you before. Allows you to deconstruct an object. So why is this important? Because now, if I know that the record comes with deconstruction, it's value-based equality, it has all these amazing things, I can use it very nicely with pattern matching. So here, I've introduced a record, which is a reference type. It is a class behind the scenes. This here is called test result. The idea is that I've done a test at university, and I might have done that quite a few times. And then it has the latest test date, and then I've introduced another deconstruct method. So with these record types, which is really reference types or classes behind the scenes, I can also have a body for that record to introduce methods and properties and functionality. And the reason I've introduced my own deconstruct is because I want to also know if this test has been archived. So when you pull a test result apart, you can say, when was this test done? How many days ago was that? And is it an archived test? And those properties or those values has nothing to do with the parameters that I actually require on my record. I've computed them, so someone that deconstructs this can get a little bit more information, a little bit more detail that they can then match on. So that's powerful. And a little gotcha here is that it does generate a deconstruct method with 2 out parameters. So therefore, you cannot have 2 your own. You have to always have a unique number of parameters. It won't tell you that you have, but when you start using it, you'll notice. And then I have 2 other records. Either you passed the test or you failed. They just inherit from this base record, which is really just a base class. Just a very concise syntax to write new classes. It's nice for DTOs and so forth, but cannot be used with Entity Framework, unfortunately. With that being said, let's head over to this program file that I have over here. Now, I'd like to start using pattern matching with my record type. The first thing that I'll do is that I'll introduce a test result. I'll call this test result, and we'll set this to a default value. I don't care. This can be null. If I were to access a property here down at the bottom, it would complain that this would potentially be null, right? But I could then, of course, write a pattern to test this. If the test result is null, or is not null, right? But I could also say, is this test result a passed test? Let me get rid of this here. If it's a passed test, I know that it's been instantiated to one of these types. I can be certain that there's an instance. It's not null. So now, if I want to use this, let's call it passed is equal to test result as passed. But I'd really not like to do this. And as I showed you earlier with the is string line, I could do the same type of thing here. The beauty of pattern matching is that we've already performed a type check. So how about I say passed here instead, and I get rid of this line that I have here. And now, this is the correct type within that scope. So all the patterns that we have, we can use them with if statements, switches, and switch expressions. But the type pattern I've showed you, we can also say that if this is a passed test, and I want to check the property number of attempts, this is a property pattern. And now I want to use, together with that, I want to say, well, if it's more than 3 times you've attempted this, maybe take the class again. I don't know. So we can construct really complex patterns that allow us to write code that we couldn't really do before. But we could also say that, well, if it's more or equal to 1 and less than 3, for example, this here is now combining multiple different patterns together. And as I mentioned, we can do this with the switch expressions. So let's say that we want to get a string representation of whatever this result is. We could say if the outcome is based on the test result, we'll introduce one of these switch expressions. And I want to take exactly this thing here. Let's take that. I'll get rid of the if. And then I could use this inside that block. Notice how it complained if I didn't have the underscore here, because it knows that I haven't checked every possible way of this permutation of this object. That's why we add this little wildcard. The underscore, the discard, is the I don't care symbol. A little thing here is that I could say var object, for example, and this here would be the same as saying the discard. It would match on the same things. So this here would actually also match on a null. Okay? Pretty cool. I think this is great. But we can also, as I mentioned, use the deconstruct. So where does this come into the place? I could say that, well, if this thing can be deconstructed into something I don't care, and some variable that is less than 10, and I don't care about the other one either, this here is super understandable. It's extremely confusing. It is. So how do we make this less confusing? Well, it also supports named parameters. But in order to use that, the IntelliSense doesn't tell me at this point. So I'd have to go into the class and copy that over. Surely enough, that becomes a little bit less confusing, but it's still not the best. So in my personal opinion, I'd much rather go with the property pattern. So when is this useful? If you have a tuple. If the input here would have been a tuple, let's say 10, 20, and you want to create a map for this, for example. Say, if the status code is 200 OK, and it had some other value over here, right? Then we could write a mapping for this, which is where this becomes rather powerful. I think that these patterns and how to use pattern matching is pretty amazing. And we can combine these as much as we'd like. We could add OR patterns. We can construct more complex things, but we probably shouldn't by now. So with that being said, I think patterns in C#, all of these patterns are going to make most of our lives easier. Hopefully, we'll all be able to write code that makes more sense. But if abused, it can end up not making any sense at all. Actually, let me show you a case where it doesn't make any sense. We could say, we could negate this entire expression. And now, who knows what this will do? Do I now care about this thing? I don't know. Is it more than and equals to 10 now? See, this can be very confusing. So again, like any language feature, you should always use them with caution. But when it comes to code like this, it becomes even more important that you don't do the wrong things. So I mentioned that C# introduces records, but we can also do record structs. That depends on where you want your data to be stored. If you want data on the stack or the heap, you could use either record class or record struct. If you use record struct, it's not going to be immutable by default. And what I mean about that is that if we go into Visual Studio, and let's say that I have a record person. It's a good example. If I can type, which I can't, name, int age. If I have this record here now for Philip is equal to new person and some age. Here we go. Now, of course, I can't change anything here. Name, and this is annoying, it should be name. There we go. I can't change the name after it's created because it's immutable, right? Which makes sense. But for a record struct, that would be possible, right? So if it's stored in the stack, it's no longer immutable. So how would we make this immutable? We make it read-only. Just add more keywords, and it will all be fine. If you imagine a feature is not there, it's probably there. Just use some other keyword. While we're inside Visual Studio, let's go through a few more of these features. They also added, so this here is a top-level statement. It allows me to write code inside a program.cs, which is then compiled into the traditional program.cs. It's useful because you can now mock or test, I wouldn't say mock, but you can test features. You can bring in packages, test small features out, and write code quite concisely inside this very small class. But with that, they want to make it all more like fluent, less levels of indentation, and look more like, I don't know, Python? Look better. Anyways, what we can do here is that we can introduce something called file scope namespaces. So traditionally, if I want this entire thing, or all these record types, to be inside a particular namespace, I'd have to say namespace NDC, and I'll have to bring this into one of my, like this here, and I'll have to indent all of this here, and it's one layer of unnecessary indentation. And if you're one of those people that uses spaces instead of tabs, and someone else uses tabs and not spaces, this here is going to be annoying when you check this into source control. Right? So instead, we put a semicolon here, and this entire file is now inside this namespace. Small thing, but it removes one layer of indentation, which is pretty cool. Now that I've changed this to namespace NDC, if I go back here and try to use my test result, that's of course not available, right? Because I haven't brought in that namespace. And if I change this in one class and introduce that file scope namespace, I'd have to go through all my files to add all the namespaces. But they've added a fix for that. So now, instead of having to do using NDC like this here, I can just say that for my entire project, use that namespace NDC. And all the types from this namespace is now available through my entire class or through my entire application, which isn't too bad. I think that's a nice feature. And you'll normally see this in, for instance, a usings.cs or global.cs or whatever you want to call it. You can store that in a separate file. So even with C#10, there's quite a few features. Like we have the record structs. There's some other improvements. We have the global using directive file scope namespace. And they've extended the patterns even more. So as you'll notice, a pattern of C# is that they're introducing more patterns, which is good. They're also improving lambda expressions and doing quite a lot of things, like allowing constants in interpolated strings. I have a slide for that in just a second here. But then they're allowing us to do a whole lot of things. So still, C#10 keeps evolving. C#11 is going to evolve. There's a whole range of features that could potentially go into C#. And I've had some discussions with developers that have been working with C# and other programming languages for a long time. And it is starting to get a little bit confusing, because now we're going to have fragmented applications. People in one camp will use all the new features. People in another camp will use all the old style features. So the solution to that is just talk to your coworkers. Make sure you're on the same page. Introduce analyzers to analyze your code, so you code the same things or have the same style. Now, constant interpolated strings would allow us to use constant values in interpolated strings, which is a nice feature as well. But even better than this, like, maybe not all of us are doing constant strings all over the place. So a more useful feature is that in C#9, if you were to create a lambda, you'd have to explicitly define which type of lambda this is, which just, why couldn't the compiler just figure this out? We could also turn this around and say var parse is equal to new func of string of int, and then pass that into the constructor. But again, that's too many characters. So instead, the compiler is now going to infer this for us. Nice feature, nice addition. And we're going to see more of this. C# is going to look at your code and try to analyze things for you. It's going to generate code that makes all of our lives easier, because if it can infer something, maybe it can also find errors. Maybe it can also let you know that you're doing things wrong before you know you're doing it wrong. Another thing in C#10 is that they're now allowing to do attributes in lambdas. So this here is a minimal API. There's a little bit more code to this here, but if you go into the CLI, the .NET CLI, and type .NET new web, you'll get something that looks like this here. So it creates a console application that has a few of these different method calls where it passes an anonymous method into it. It's a lambda. And to be able to use this fully, to make it actually useful, they have to introduce attributes on lambdas as well. So you'll see that here. So I could say that from the header named content type, map that into my type called content type, right? So that's all C#8 or even 7, all the way up to C#10. There's quite a lot happening in C# as a programming language. So what's next? About 4 minutes to cover the next 10 years of C#. Probably not. So the reason I don't spend much more time talking about C#11, C#12, C#13, even though C# is going to get a new version release in a couple of weeks, from experience, there's going to be a feature or two that they actually remove the day before release. So I try not to talk too much about that before it's actually on the market. But there are a few things that I do believe are going to make it into the cut. As I mentioned, a pattern is to add more patterns. They're going to make it easier for us to match on lists, to say that if this list is an instance, give me the start, give me the end, or give me a portion, and that will probably be used in conjunction with a range syntax, for example. You can slice things, you can use the span patterns. There's a whole range of things that we can do. They're introducing the name of operator. They're finally going to cache delegates for static method groups, which is a huge performance improvement if you've ever run into this issue or run into that. We looked at the required properties. If I had enabled preview features in my project and installed .NET 7, I would have been able to use that. This would then require me to always set this to a value when I instantiate my object. They're going to change the ways that we can write strings, and they're going to allow static members in interfaces. One more cool thing that they're going to do is that introduce something called UTF-8 string literals. So how about I have a string here, right? Why not just implicitly allow me to convert that into a span of bytes? A span allows me to work with data inside a large collection. Like in this case here, it would be an array of bytes. And instead of having to copy that all over the place and have to, when I slice pieces off it, I would have to copy things, this here is much more performant. And they've rewritten a lot of things in .NET, in ASP.NET Core, to incorporate this, to introduce some performance improvements. And finally, they're going to do generic attributes. I did ASP.NET, not Core, the legacy stuff, web form stuff, and then MVC. And this is something that I've wanted for a very long time. Like you write an attribute for one of your controllers, and there was no way of doing it generically. So you ended up doing some nasty things to get around that. But they're finally going to do this. And one of the most important things about .NET and C# being open source is that everyone in here in the community can contribute. And they did. They told the compiler team that we don't want a certain feature, and they removed it. They were going to add double bangs. Like if one bang wasn't enough, they're also going to introduce this double bang thing to say, if this parameter that was input into my method, if that is null, throw an exception. And that would just happen by default. And no one liked that, or at least not a lot of people. So with that being said, there's one final thing. I mentioned that they're also going to do these static abstract members in interfaces. So why would we do this? Because in this case here, if I have an interface that tells me you need a property that is static, there's no way to enforce that. But what they're doing now is that this preview feature allows us to say that this is an abstract thing. And now the class has to implement that. It's a nice addition, if you do singletons, which I think a lot of us stopped doing 10 years ago. So with that being said, if you like this, I do have quite a few courses on C#, on data access, advanced language features, where I go through all of this in greater detail. There's quite a lot to talk about in just an hour. There's so many things happening to C# as a programming language. But I hope you got a nugget or two out of this here, and that you're going to experiment with record types, pattern matching, and hopefully, if you enable nullable reference types and treat warnings as errors, and then just leave work, please send me a tweet and tell me about the experience. All right, I hope you like this. Thank you so much. I'm Filip Ekberg. Don't forget to vote.